Hello, these are the second set of word problems that go along with systems. All right, so this is word problems part 2. And why oh why that was ever the color I was using, I don't know. But anyway, this is word problems part 2. These are still involving systems of equations. So you will still see that we will have 2 equations. And please notice what I have asked over here. Identify your variables. Set up a system and then solve for your variables. Also, I would add to that to be sure that you are also labeling your final answers since they are applications. There was a slight delay with my stylus here. All right, so I'm going to go to the end to see what is it they want me. Find the cost of each vegetable, and I see there's squash and zucchini. So I'm going to just stick with X and Y. So X is going to be my price for squash, or my squash price, and Y is going to be my price for zucchini. So 5 squash, 2 zucchini would be 5x plus 2y. And this is only $1.32. They must be in season and really cheap right now. So we do need to include that decimal. Otherwise it would be $132. And then 3 squash and 1 zucchini is 75 cents. So if we would add these together now, they do set up nicely for elimination like we did the last time. But if we would add these together now, nothing would be eliminated. And so what we're going to do is multiply that second line. I'm going to multiply that second line by -2. To make this -6x, -2y is -150, or just 1.5, but it is negative. The top line would remain the same. So top line is remaining the same, 5x, 2y, $1.32. We put these together, we get -1x, y's eliminate, is -18 cents, which would mean x is positive 18 cents. So that would mean that the squash, so 18 cents for squash. Notice when you use a dollar sign, then you're using also the decimal, because 18 cents is 18 hundredths of a dollar. Do not use the decimal point with the cent sign unless you mean it's less than a penny. I know you see it places all the time. It drives me crazy. So let's go back, figure out how much that zucchini is. So I can plug it into either equations. So if I go to that top one, I'm going to do 5 times 18 cents plus 2y is $1.32. So that's 90 cents. If I take the 90 cents away from the $1.32, I get 2y is 42 cents. And then when we divide, we get y is 21 cents. So it is money, so it's okay that it has a decimal in the answer. And this was for the zucchini. I always question if this is actually spelled right, but we'll go with it for now. So very much like what we did last time, if you did the elimination work, that should not be a problem. In number 2, with Ben and Judy, again, it's going to be elimination. So I will warn you that when you do number 2, well, I will warn you first that I'm getting ready to erase. But I will also warn you that when you do number 2, Ben and Judy are both making very small hourly amounts. Like perhaps they're kids and they're working, doing work for their grandparents or something. But they're not making minimum wage. So don't be surprised by that. But you're going to end up with some Ben plus some Judy, or Judy plus Ben equals an amount. Judy plus Ben equals an amount. When we get down to number 3, we have something that is different than what we've done so far. And so I will be sure to work number 3 here with you. And in number 3, it says Rob has 40 coins. They're all dimes and quarters, worth $7.60. How many dimes and how many quarters does he have? So that's our goal to figure out. So I'll let X equal dimes, Y equal quarters, and if you want, you could use N and Q, be all fancy that way. So there are really 2 equations here, just like there have been. One of them has to do with how many coins. Just like if I was counting them like a 3-year-old or a 4-year-old. 1, 2, 3, doesn't matter if it's quarter or dime. I'm just counting the coins. There are 40 of them. So the number of dimes plus the number of quarters is equal to 40. Notice that one is a nice simple equation. I'm going to make a little note out here that this is my simple equation. It's like so simple that sometimes people overlook it. That's my simple equation. My other one is going to be all about the money. All about how much are these things actually worth. So how much is a dime worth? 10 cents, right? So I'm going to take a little liberty here, and I'm just going to say 10 without a decimal, which is okay as long as I take the decimal off everything. So I'm working like in pennies. So a dime is 10 cents, a quarter is 25 cents, and $7.60 is 760 cents. Now, if you want, you could leave the decimal in all 3 places. Basically, what I did was just think I'm multiplying all the way across by 100 to make them whole numbers. And then now this should look like something I could easily use elimination. I'll have to multiply. I'm going to multiply this top equation. I could do it times negative 10 to get rid of the x's, or negative 25 to get rid of the y's. I'm going to do times negative 10. Just won't be quite as big that way. So remember, all the way across. So I really don't need that plus sign there. I can just go ahead and write minus 10y, and then is equal to negative 400. Second line's not changing, just rewriting that underneath. So really, after I got this set up, you could probably stop watching, finish this problem on your own without any issues. It's just getting it set up because it is different than what we've done so far. These would eliminate, of course, something better eliminate. I have 15y, 360. So this would be y is 24. So I know there are 24 quarters. And remember, since it's a word problem, I don't really care if you tell me X or Y first, but be sure that you put a label with it. So I'm okay with if you write 24 quarters first, but don't just write the word 24, or the number 24, I should say. We're going to take the 24 back. That first equation certainly looks like the easiest place to figure it out. If I said x plus 24 is equal to 40, subtract 24 from 40, and x must be 16. So 16 dimes. So 24 quarters and 16 dimes, or 16 dimes, 24 quarters. Again, I don't care which order you're giving me them, as long as they have a label with them on the applications. And then you could check that to make sure, is that indeed $7.60? So 24 quarters, 4 quarters and $1, so that would be $6. And 16 dimes, 10 cents a piece, that would be $1.60. That would add up to $7.60. Number 4 is worded a little differently, but the intention is the same. We are not saying that Kelly has 24 dimes. We're saying Kelly has 24 dimes and quarters total. So it's going to be very similar setup, but with 24 where the 40 is, and the 360 where the 760 is. So I will leave that one to you to work on your own. It is very similar setup to what we just did in number 3. Now we're going to move down to number 5. And as much as it seems like number 5 is very different, it's not talking about coins, it still will have a simple equation and a money equation. Okay, it's still going to have a simple equation and a money equation. Try to give myself enough space to write here. So how many of each type of ticket? Well, let's see what type of tickets were there. There were student tickets and adult tickets. All right. So X is going to be, and we're looking for how many. So I'm going to say the number of student tickets. It's not how much they're worth this time. It's how many of them. And Y is the number of adult tickets. And like I said, we're going to have a simple equation and a money equation. So my simple equation is just going to be that X, the student plus the adult tickets, the total number of tickets is 530. So it's so simple we almost overlook it. The other equation, everything with a dollar sign goes in that money equation. So student, $3 each, so that's 3x. Adults, $4 each, so 4y. And the total money, receipts, the total money brought in was $1,740. And then from there, we're in prime shape to solve that. I'm going to take this one and multiply it either by -3 or -4, depending if you prefer to get rid of the x or the y. I'll go ahead and do times -3. And I'm going to write it underneath just because that's the way my space is working out this time. And that would be -1590. Please don't forget the negative on any of those. That will really foul things up. And I come out with 1y, or just y, is equal to, what is that, 150? 0, 5, 1, yeah. So y is 150, and if x plus y is 530, then x plus 150, 530, take away 150, and x would be 380. So this would be 380 student tickets how about TIX? There we go. And 150, 50, not 56, adult tickets. And if I did 380 times 3 plus 150 times 4, that should come up with the total money. Now, on the back side of this page, number 10, so the bottom of the other side, well, it's not going to be the back if you're doing it on the computer, I get that, but number 10, same setup. All right, so when you get to number 10, same setup as number 5. Again, a simple and a money equation. Perfect. Okay, number 6, I will tell you in advance, is not like any other problem that's on the paper. We'll look at it together. If you take geometry next, you may see that you have some problems somewhat similar to this. You do use a lot of your algebra equation solving in geometry. So we will do number 6 together. You will not have something like number 6 on your quiz, but just to expose you to the different types of problems that you might see. So it's talking about a rectangle. That's why I mentioned geometry. So it's talking about a rectangle. It says the length of the rectangle is 4 centimeters longer than the width. And we're supposed to find the length and the width. Instead of using x and y for just a wild change in things, I'm going to go ahead and say that L is length and W is going to be my width. So those are the two things I'm looking for. I have my variables set up. The length is 4 centimeters longer than the width. So the length is 4 plus W. Not 4 times W, not 4W, but 4 plus W. Or W plus 4 would be the same thing. The perimeter is 80. So think about perimeter. This is a rectangle. Pretend with me. It's not a very good one. But perimeter means we're going around the rectangle. And you might be familiar with that formula. The formula for perimeter of a rectangle is twice the length plus twice the width. Because there are 2 lengths, this side, and 2 widths, those 2 sides on the sides. So W is width. So then if I know this case, my perimeter is 80. Now I'm just going to go ahead and write that on the opposite side though. I'm going to go ahead and put 2L plus 2W is 80. Now, the earlier part of today's lesson was about substitution and special cases, but substitution. But we haven't used substitution yet on these word problems, but we're getting ready to now. So here, my lengths and widths in both equations are not on the same side, but this says that L is equal to 4 plus W. So this is going to be a nice place where we can substitute this where the L is. So I'm going to rewrite that second equation about perimeter except that where the L is, I'm going to put 4 plus W inside some parentheses, so that when I take it times 2, I take the entire thing times 2. And now I'm going to solve this, and it's going to allow me to find my width. So I'm going to distribute. I'm going to combine like terms. Then I'm down to my two-step equation. So we'll subtract 8. No matter how I do it, there's never enough space. So 4W is equal to 80. And then I'm going to divide by 4. And W is 20. So now I know that something doesn't feel right because I didn't subtract. If I wasn't too lazy to re-record, I would. But instead, you just get to know that everybody makes mistakes. Everybody has those days. 80 minus 8 is 72, not 80. Now when I divide by 4, I get that my width is 18. I was doing a little thinking ahead and knew that that was not going to work. So my width is 18. And if my width is 18, then my length is 4 plus 18. So my length is 22. So then I would say length 22 centimeters. And my width is 18 centimeters. And if I would check that, if this was 22 and this was 22, and this is 18 and this is 18, if I added up all the way around, would it add up to 80? Yes, it would. It would not have if I had left the width at 20. So, there we go. All right, so there's your one geometry type question in this lesson. So keep in mind, you might see things like this pop up because in middle school math, there is a lot of basic geometry that involves perimeter and area. And so it's really still considered fair game to toss that in algebra. It's just, if you've been away from it for a while, maybe a little rougher because you don't remember that. But I'm here to help. Okay, so next up, we have a few other kind of somewhat random where we're going to be using substitution. All right, so just a warning that these next ones, you might be able to set them up to use elimination, but they may lend themselves better to substitution. So here, instead of dimes and quarters, now we have nickels and quarters. So I can choose which way I want to go with this. If I say X is my nickels, or you want to use N, that's okay too. Y is my quarters. And there is still going to be a simple equation, but it's not going to be X plus Y because they didn't tell us the total number of coins. Instead, they told us there's 3 more nickels than quarters. So in other words, if there are 3 more nickels than quarters, that means the nickels are 3 plus the quarters. So like if quarters was 5, nickels would be 8. And then the other one though, this was my simple, the money equation is very similar to what we did before. So a nickel is worth 5 cents. A quarter is worth 25 cents. And then we're 285 is 285 cents. But now this time, instead of eliminating, you could move things around so that you could eliminate if you really want to eliminate. But we could also just plug in, substitute 3 plus y for the x, because it's telling us that's what x is equal to. So I would have 5, and then inside some parentheses, instead of writing x, I'm going to write 3 plus y, because it's substituting in for the x. The rest of that equation stays the same. So then I'm going to distribute. That is a 5 to 85. Combine my like terms. Subtract 15 on both sides. This time I'm going to remember to subtract 15 from 285, 270. Divide by 30. And I got y is 9. And then if x equals 3 more than y, so x equals 3 plus 9 would be x is 12. So then we're saying there are 12 nickels and 9 quarters. And then the last thing I would do is check and be sure that this does add up to $2.85. So 12 nickels, if I just divide 12 by 2, that gives me 6. So it's 60 cents. 9 quarters, well, I know 4 quarters and $1, so that's $2.25. Or I could just do 9 times 0.25. And then when I add that together, I do get 285. You could also check it in your actual equation. I just usually go back and check, like, in the word problem, does this make sense? And so that's my final solution, 12 nickels, 9 quarters. Or if you wanted to tell me 9 quarters and 12 nickels, perfect, as long as they're labeled. All right, I've moved on to number 8 here with Ann and Betty. And Ann and Betty together have $60. Ann has 9 more than twice Betty's amount. So I'm going to help you get these set up, 8 and 9, and then leave the solving to you. So what do we want to know? We want to know how much money does each have. So we want to know, and if you want, you could still use X and Y. I'll just venture out and use A and B. I know, I'm living large here. So if you want to stick with X and Y, you certainly can. So together they have $60. So that certainly sounds like Ann's money plus Betty's money is $60. Doesn't mean if we multiply their money together. It means if we add their money together. And then we have Ann has, so Ann's money is 9 more, so 9 plus twice Betty's. Twice would mean 2 times Betty's. And there's my setup. A equals 9 plus 2B. So if one of the variables is by itself, it's set up better to use elimination, or substitution. You could still move it around and make it elimination. But it's better to use substitution. Excuse me this morning. So this would replace this. You wouldn't need to write parentheses around it since it wasn't being multiplied. So you're going to have 9 plus 2b plus b is equal to 60. So I will expect that that one actually gets finished, but you have it set up now. And number 9, we have M&Ms. So we have red and brown M&Ms, and we want to know how many of each, and you might be able to just figure this out without writing an equation, but I'm going to follow the rules. So if I said that R is my red M&Ms and B is my brown M&Ms, and there were 13 red and brown, that's supposed to be total. So red plus brown is 13. And then it says there's one more red than brown. Now, there's more than one way that you could set this up. You could say R equals B plus 1. But also, if there's one more red than brown, that would mean that if we take the reds, take away the browns, the reds have more, reds take away browns would equal 1. And then you could use elimination. Instead, you could say R equals B plus 1 and use substitution. You do not need to do both. Okay, so you're going to use this one and then one of these two, not both of them. Okay, one of them. And then depending on which one you choose to use, you'll use either elimination. If you leave it the way I first had it, this would just be elimination. And it would be nice, easy elimination, no multiplying necessary, because the b's would already eliminate. And then number 10, as I mentioned before, number 10 is very similar to number 5 with a simple equation and then a money equation. Everything that has to do with money goes in the second equation. All right, this finishes up systems. We'll be reviewing for a short quiz next. So stay tuned for that. Thanks.